All right, guys, here's example 4 and 4.5. For each of the following, choose a linearization with the center not at x equals a, but a nearby value, okay, a nearby a value at which the function and its derivative are easy to evaluate. State the linearization and the center that you're going to pick. So, as you can see, this is giving to you f of x equals third root of x, okay, and an a value that they pick is 8.5. There's no way that I can do a third root of 8.5 in my head right now, okay, and get a good answer. So it says here, pick a nearby value that is easy to calculate, okay. So my nearby value, class, it's going to be 8, okay, because I can do third root of 8. But first, it says I need to also do the derivative as well. So let's find the derivative first. F prime of x is 1/3 x to the negative 2/3, okay? So I'm gonna, and if you want to, you don't have to. You can rewrite this as a radical, so it's easier for you to calculate if that's you. And again, you do not have to. So my nearby value, I can't spell near, can I? Nearby value. I wanna pick a number or value that I can use third root in. So I'm gonna say nearby value is 8. Yeah. Okay. So I'm going to evaluate this as x equals to 8. Okay. So let's plug it in. 1 divided by 3, third root of 8 squared, which is 1/3. I can take out 2 twice, so that's 4. So this is going to come out to be 1/12. So that's my nearby value. Okay. But it also says choose the linearization. So what that means is I need to use my linearization graph. So L of x, remember this, equals f of a plus f prime of a times x minus a. Okay. So I'm going to plug in 8, okay, for my f function because that's the value I've chosen. Here's my f function. When I do f of my nearby value, which is 8, which is really third root of 8, which is 2. So my f of a is 2. Okay, so this gets a 2. Then plus f prime at 8, I already found. This is right here, 1/12, plus 1/12. Then I need to go x minus 8, okay? So 8 is the nearby value that I have chosen. So let's make this prettier than what it is right now. So 2 distribute, so that's going to be 1/12x. When I distribute, that's negative 8/12. Simplify that, divide by top and bottom by 4. So that's going to be negative 2/3. Okay, combine 2 and negative 2/3. So my answer is going to be 1/12x. This is the linearization that's going to help me approximate my function. 1/12, and that's going to be 2. Convert that to 3 over, denominator is 3, so I will need to convert that into 6/3. So 6/3 minus 2/3, so that's going to be 4/3. So that's going to be the linearization approximation of my function. And that's exactly what you have to do. Okay, it says for each of the following, choose a linearization with the center not at x equals 8, but a nearby value. Okay, I don't want 8.5. I want a nearby value that's easy for me to calculate. Okay, and it says center. Say the center. I pick 8, so my center is 8. Perfect. Similarly to cosine, okay? Cosine, there's no way I can do cosine of 1.7. That is not going to happen in my brain. But would you agree that cosine, easier values to pick are 0, pi/2. These are nice ones. Even pi/3, pi/6, and so on, right? Things that you can calculate without a calculator. Well, pi/2, it's about 1.5-ish, okay? And so nearby there, that's what I'm going to pick. So center, which is AKA nearby point, is going to be pi/2 for me. So I'm going to box that up because it said state that. Okay. So I'm just now going to do the derivative. F prime of x equals derivative cosine of x is negative sine of x. Evaluate it at x equal to nearby point, which is your center, pi over 2. So that's going to be negative sine of pi over 2. Sine of pi over 2 is 1, that's going to be negative 1. So my slope is negative 1. In addition, my linearization, if I can say that quickly, I need to have f of a. So your f function is cosine. So f of pi over 2 is cosine of pi over 2, which is 0, which is okay, no big deal. Then now let's plug into my linearization function. So L of x equals f of a plus f prime of a times x minus a. This is my function. Okay. So L of x equals f of a is 0 plus f prime of a was negative 1 times x minus, sorry, my nearby point was pi over 2. Let's distribute. Okay. This is going to give me a negative x and a positive pi over 2. So this is as far as I can go in terms of my linear approximation function. And this is the end of today's video.